Welcome back to another episode of the Blockburner Podcast. I'm your host, William, always here with your co-host, Iman.
What's going on, dude?
And on the sticks, we got TJ.
Hello.
And then finally, today joining us, we got Morgan Rockwell from Mycosoft. Thank you for joining us, man.
Yeah, thanks for having me.
Yeah, so
Absolutely, dude.
I guess we got connected with you recently. I guess you reached out to Iman, and you've seen what we've been working on with DMT stuff. And
yeah, and I just want to really stick it to Will one good time because he's been bantering on and on and on about like physics and its crossover into Bitcoin and such.
There.
Which is great, and I love the discussion. Right? Thanks, Will, for reinvigorating my mind. But now you're introducing another avenue of like scientific exploration, right? It's like, where does biology and Bitcoin specifically intersect, right? And science in general, right? So I figured, let's kind of like go down this rabbit hole because we've created a rabbit hole of our own in this whole digital matter theory concept. That's it can go as deep as Will takes us with these thermodynamic
explanations,
right? So yeah, I'm really curious and interested to see like what it is you're experimenting with. So if you can, just give us like a beginner like sum up, because I know it's what you're focused on is very broad in application and it has a lot of applications and stuff.
So like for context, before I started working on what I would call the biological computer, I was working on virtual computing. And so one of the reasons I kind of understand what you guys have been talking about, the digital matter theory, is I spent a good 3 years building a application-specific integrated circuit, a ASIC mining chip that is coded to do SHA-256 inside Minecraft out of redstone.
Dude, that's cool.
And I was doing that as two parts. One way to make a chip that can be copy and pasted, but also play with physics and see if thermodynamics can be somewhat tamed in the computing world in a virtual way where we can make computing non-thermodynamic because there's no heat loss in Minecraft. And if you're running compute in a virtual computer, instead of electrons, you're using redstone that turns on and off and does binary and stuff like that. Would physics be a variable we could change to do compute? And so that was a big experiment I spent a lot of time on, and it's still not done. And it kind of paralleled what I'm working on now in the mycological world is a biological computer. And those two things kind of go hand in hand. They have a lot of interoperability. And the goal would be, we want a computer that we can copy and paste so we don't have to manufacture it, the virtual computer. And we also want a biological computer, a computer that we could grow and have circuitry rewire itself, almost what we would call wetware. And so in the context of what I'm working on is I deal with fungus every day. I am the founder of a company called Mycosoft, and we are building hardware and software that interact with fungus in different ways. We have some very low-level, street-level devices that would basically collect spores out of the air. And we have some very far-reaching scientific devices that would collect electrical signals out of the ground, directly interacting with fungus on the forest floor. And then one day we have this device we're eventually going to engineer, which is an electronic circuit board that basically stimulates mycelium in a petri dish, and petri dish stimulates the circuit. And so you could plug a petri dish basically into a computer and interact with the tissue in the petri dish electronically. And so there's a lot of work that needs to get done to make these tools usable. And one of the big things is data. And so I have been building this database, which is called the Mindex, the Mycological Index. It's kind of like a giant Rolodex of all the fungus that exists on Earth, where they are, what they do, what they look like, what compounds they can make. And then there's a section of this database that is all identity data, like DNA. And so what I started doing in the last couple of weeks is taking snippets of the DNA of each mushroom species, and DNA is a large amount of data. And so I take the piece of data that says this is this type of mushroom, this is a a cordyceps mushroom, or this is a lion's mane mushroom, or this is a portobello mushroom. And you take that snippet of DNA, and I've been compressing it and inscribing it in ordinals to basically embed the DNA, who found it, where it was in the Bitcoin blockchain in a way that can be done with parent-child recursive inscriptions, so that one day if someone takes that DNA out of the blockchain and says, oh, this is a nice piece of DNA, I want to try something with this tissue, and they do something commercial with it, potentially making billions of dollars, I would like the person in the forest down in El Salvador that found that mushroom to somehow get recognition, if not royalties, but at least recognition that that tissue was discovered by someone down the chain.
Mm-hmm.
And so I'm using Bitcoin's time chain as a supply chain record system,
Mm-hmm.
you know, and I've been working on Bitcoin for a long time, and I remember long years ago in the before time when we used to think that Bitcoin could be used for all kinds of cool things like records keeping and voting. And I did a lot of machine interfaces with Bitcoin in the early days. I made the very first Bitcoin ATM in my garage in 2010. And so I have a lot of experience in making Bitcoin do things that are not necessarily financial, but using other potentials for the blockchain's database system and asset ownership system and key management system. I think there's a lot of cool things we could do with Bitcoin. So the real goal is to basically make it a ownership of data system. And I think owning money is great. And I think maybe owning your records is a good use of Bitcoin, but really owning say DNA or data or scientific discoveries, that goes into the world of like owning a trademark or a patent or a copyright too. But owning DNA is a contentious thing. You know, we're in a world where biotechs think they could own different strains of cannabis and different corn and wheat and different organisms because they patented DNA that they've changed. And so that DNA is kind of hidden in the world of the biotech servers, and the public doesn't get to see what's going on in that genetic world. And so I feel it's a good idea to just shove all the DNA into Bitcoin, so that everyone can see what's going on. And then there's records of mutations and changes and modifications to DNA. And in the world where there's CRISPR, if you don't know what CRISPR is, it's a tool to edit DNA that is pretty much available to anyone on Earth now for very low cost. You can go modify any organism's DNA and to do anything you want. It's like a word processor for DNA. Now that that's available to everyone, I kind of feel we need a receptacle of all this DNA activity, and I think Bitcoin is perfect for it because it's distributable, it's monetizable, and it's, you know, untamperable in a sense that when one letter of DNA changes, it's a different organism, you know? So you got to have SHA-256 hashes and encryption and ownership and timestamps to make sure things are organized and not changing. And so I think Bitcoin is literally like the perfect example of the DNA database. So that's what Bitcoin is now, the DNA database. I that's what I'm doing to it. And
you mentioned
there's going to be a lot of people that don't like that maybe, but
right.
That's
you mentioned
my decision now.
a before time in Bitcoin. What would you say is the biggest difference between the before time and now, where there's like this huge interest in ordinals?
I think the concrete like status of Bitcoin as existing and never not existing. There was like this BC, you know, AD moment. I can't really tell exactly when it was, but there was a long time where Bitcoin could die. Bitcoin literally could be destroyed by, you know, different computing systems, different issues. Not necessarily like the banks and the governments, but there were a lot of technical things that were in the way of Bitcoin being like something that's going to be here for 1,000 years. And then it passed that point, and now it's definitely going to be here till 2145 when the last coin's mined, and it potentially could be here longer than that. And there's no doubt in my mind, and I think a lot of people in the world, that Bitcoin will never go away now. And so, but but also there's like a lot of things that happened before and after that moment, whenever it was. And there was a lot of experimentation on what Bitcoin could be used for, how it could be used. And then there was experimentation on how it should be regulated. And that's still up in the air on what words the governments want to call it. And there was also a social uprising, you know, the block wars and things like that, in that it was more of a unified concept and it became very fractured, almost like Christianity at that point. And now, you know, we have not just forks, but we have different perspectives on Bitcoin and how it should be used. And we put these words around each other in a very unscientific way, like cultism. You know, there's the maxis and the laser eyes and the ordinal people. And to me, we're all just Bitcoin users. We're all internet users, really. And I don't even really try to separate Bitcoin from the internet. It's just I separate the internet from a computer. We're all just users of the computer. And I think the words have fractured. The people have fractured with the words. And then ordinals, to me, is a good collection of marketing words that Casey has made, inscriptions and runes and etching. And so it is an example of what you guys have done is putting like the digital matter theory, a word to some concepts. It builds a cult following. It also builds a scientific community around it. You know, we didn't really have particle accelerators until Einstein put out a paper that said particle in it, you know. So you have to have the right words. And I think at the before time there weren't too many good scientific words. And I really think putting physics and science back into Bitcoin's conversation is vital. And there's too much, in my opinion, cultism. And I created the Church of Satoshi in 2012. So I'm all for building cults. But, you know, you need to have a good set of vocabulary always in everything, whether it's physics or biology or computing or art. You got to have a good like set of words that can be used for all demographics of people, all intelligence levels, all cultures. Yeah, if we don't have the right words, then it doesn't, you know, stick with everybody. And like having a theory is great. We need to have a theory. Like to me, Bitcoin was a theory. It's an experiment.
Right.
And like to put the digital artifacts in a theory of its own, and like I call ordinals ordinal theory because it's a mathematical theory. And I think that conversation validates it more, at least to me, all of the things that are happening in the now time. The before time, there was garbles and no words of what we could do with this technology, but not white papers and not vocabulary and not theorems. It wasn't that way yet. And it's happening now a lot because of people like you and people like me and some other people that are just actually thinking more concrete about it, you know. And to me, computing is cool science. We just need to keep pushing it forward, you know. You know, there's a lot of conversation about AI, but we can't let that dilute the potential of the distributed computing system that we've built. The Bitcoin world is a whole another branch of computing that AI is going in a different way too, you know.
Right.
And so that's one of the things I want to do. I love that. Okay, I want to build a biological branch. I want to build a database that is interacting with biology and eventually use that data to figure out how to grow circuits and grow capacitors and batteries and transistors in a way, because I think we need more branches of science and compute.
Yeah.
And you know.
Did you know that we're more than just a YouTube channel? We also built Mscribe, the first inscription platform built from the ground up for the metaverse on Bitcoin. Connect your bitmap ordinals and use our tools to bring your community into the virtual realm. Support us by joining the movement at mscribe.io. Like, comment, and subscribe for the latest alpha. Back to the video.
Can you give us like some insight into like, I guess the status or the growth phase of this industry you're kind of describing? Well, I don't even know if it's an industry yet. This growable
computer
hardware
Yeah.
systems.
I may be one of 4 people on Earth doing that. There's a
Okay.
lab, the Unconventional Computing Lab in the United Kingdom. They wrote the professor there wrote a book, Fungal Machines. So I would look that up. You just type in fungal machines in Google. It's a
Yeah.
great book, very weird, but it's about using fungal organisms for logic and computing. That's probably the only book on Earth that even describes those concepts right now. It's like a $300 book because it's very rare. But I've been connecting fungus to computers for over a decade. And in the last, say, 4 or 5 years after COVID, there's a lot of TikToks of kids connecting synthesizers to mushrooms and plants.
Mm-hmm.
And what I used to do is do that a long time ago, but with voltmeters and spectrometry machines and different electronic monitors, telemetry machines like you use on a heart, and electrocardiograph, the muscle sensors you put on your arm to stimulate. And so I took a lot of electronic read and write tools and connected them to fungi years ago. And then someone, in an intelligent way, because we all need good user interfaces, thought about connecting that voltage signal to a synthesizer. And now there's sound coming in and out of that voltage change inside the plants and the fungus. So now the public doesn't understand what's going on with this technology or the potential of it. They're seeing and hearing something going on, and that bridge made it a little bit more mainstream. It's like now the mushrooms are talking, they're making music, and that's very anthropomorphized. Humans get that. And so I should have thought of that 10 years ago. I didn't. I was like, damn, that was a great idea. They connected a speaker to the voltmeter.
Mm-hmm.
And so that's been happening in an experimental way for, I would say, 10, 20 years. But fungi, people thought they were plants 70 years ago. So this is very novel science. These are undiscovered species of Earth. Even though it's 60% of all the living things on Earth are fungi, like we don't really have too many words and understand what it is. So there's only so many reasons why people would want to do that. But like, to be very simple, like I want to talk to mushrooms because I think mushrooms are conscious. I think they're a very self-aware organism. They're the oldest thing on Earth that's been eating. And we're all fungal organisms in our biome. Every plant and insect is connected to fungus. So I look at it in the computing world as fungus is like the USB port to nature. And if we could do the signal processing, input, output to fungus, then we could do that to everything else. Every brain, every tissue, every root, every microorganism has an interaction with fungus in some way. So if we could directly communicate, read and write to fungus, then we can communicate with everything else on the planet and maybe everything else throughout the universe. Because I think it's a simple way to figure out how to communicate with fungus in a biological communication way, like turning binary into biological signals and vice versa. And then now we have a Google Translate to nature. I think that's important. We need to figure out how to talk to mushrooms and dolphins and cats and dogs long before we try to talk to aliens. We're talking to AI all day long, but some people don't even believe it's got a functioning mind or a consciousness, and we don't even know how consciousness works on a scientific level.
Right.
So I think really getting the communications down on a biological level is important. Then we could understand a little bit more about the mind, the soul, the brain, different organisms, communication styles and things like that. And so like building machines that can read and write to fungus is like a really important step, I think, for humanity to like connect with nature in a more efficient way.
What would you say is like a write function to an organism? Like what would you be able to do if you could write to fungi?
Okay, so in experiments, there's this electrical activity that's coming out of fungus when they get stimulated by nature. Mm-hmm. So as an example, when a lightning strikes in the woods, mushrooms will grow around the lightning strike. That's mostly due to a cataclysm happening, and the mushroom responds, puts mushroom tissue out, which the mushroom caps are the sex organ to put spores out and spread more of that fungus. So if a lightning strike happens, fire, electricity, vibration, any kind of stimulation that's maybe not best for the organism, it'll tell it to grow. or it responds by growing. And so you could cut a mushroom, burn a mushroom, electrocute a mushroom, punch a mushroom, yell at a mushroom, and you'll see an electrical spike in different patterns when you're monitoring the electrical activity of the mushroom. And so if that stimulates growth of a mushroom from the mycelium, then as a farmer, if I could just electrocute a mushroom a little bit and make it grow bigger or faster or stronger, then now I have an electronic fertilizer. That's a big potential for more food, more efficient food, more medicine, more efficient medicine. And then, that would be like the commercial, how everyone would understand the potential of that.
Okay.
Stimulation of growth is the basic. On my end, what I would really want to see done is I would want a specific compound to be made by a specific mushroom, because there's like a numbers game. There's like 50,000 named mushrooms on Earth, maybe 5 million that we don't even know of. And we're only about 200, 250 elements in the entire universe. So you can do the math that there's a mushroom that interacts with almost every element in some way. And they can basically take compounds and rebuild them into things. Mushrooms can make proteins, amino acids, poisons, different drugs. They can break down matter. They could break down oil and plastic. They could bioaccumulate metal. They could push metal into an enzyme and push it out somewhere else. They can make nitric acid, which liquefies all metals. So mushrooms can make anything you can imagine, and they could break down anything that is in existence, from asteroids to lava rock to metal. There's nothing in the universe that a mushroom can't eat or change. And so knowing that, I would love to tell a mushroom to make a specific compound. If I can give it food and a little bit of an electrical stimulation and say, make me iodine, make me vitamin C, make me hemoglobin, make me THC, make me a compound that grows brain cells. There's mushrooms that do all those things naturally just by living out in the woods, and they bioaccumulated some chemicals from a tree, and then they made this compound. And for some chance, there's these two chemicals in lion's mane mushrooms that regrow brain cells, and they're nowhere else on Earth. But that mushroom makes those compounds. And so something motivated it to make those compounds. What I would love to do is be able to tell that mushroom to make maybe a different compound. And if it's capable of being trained with electricity and maybe food, make this compound for me. The potential is not just like a biological computer, but using biology like a program, where I could program certain compounds to come out of certain organisms. I could use mushrooms as inks for a biological printer. And that would be the real long-term goal, is the Star Trek replicator, on a very primitive level. Make this for me, and it prints it out. Mostly food, medicine, changes the cost of food or medicine, makes maybe money irrelevant. That's how Star Trek worked. Once they had the replicator, money was irrelevant. You can make food and medicine anytime you want. And then they had the Bitcoin, became the Star Trek credit. And so like there's a lot of things I feel in science and physics and engineering we need to get done. Bitcoin's kind of there. The next thing we need is the replicator, and then we need the warp drive. And so I feel like we need to figure out how elements can be put together like Legos. And I think mushrooms are really good at taking them apart, putting them together. It's just they're doing it for their own survival mechanism. I want to see if I could train those like a dog, and like a German Shepherd, do this for me. Give it a little shock collar and make sure it doesn't bite anyone,
Well, Morgan, you are preaching to the choir here, because we talked about that a lot in terms of like, there's this physicist that talks about Bitcoin and talks about information. Well, specifically, he talks about information being like the fifth matter in the universe, the fifth like substance in the universe. Yeah. And there's like a lot of physical properties when it comes to like generating a Bitcoin, and then leveraging the whole blockchain as like a substrate layer for generating other pieces of content. And so when you're talking about like the rarest form of like, I guess anything rare, according to this physicist, is like in the digital realm, right? Because from the physical realm, we could invent enough technology to be able to put molecules together like Legos, like you're saying. And so now all of a sudden, we have infinite amount of gold, we have infinite amount of food, we have infinite amount of anything. We can just build it. And so when it
Yep.
comes to like comparing rarities, like anything physical is no longer rare. But the digital realm, that's where the rarities, like that's where they lie. That's where they exist. And so I find it interesting that, you know, we're able to think about Bitcoin and like its application in different ways other than just money. Because I feel like Bitcoin's energy input into the system, this network layer that we've created, is like a digital version of time and physics of the earth putting pressure and temperature to manifest like fossil fuels, right? And it's the equivalent of that. It's just it's in a different form, right? A digital form. And so what humans have done a good job of leveraging this low entropy state to create the industrial revolution. And so I feel like this low entropy state of the blockchain is a source of data that we can kind of leverage to create a digital industrial revolution. And so that's really like the thesis behind like the whole digital matter theory. And I feel like you can leverage that concept in ways where, like you're saying, you can inject this hash value that represents this piece of DNA and like
Yeah.
this source data, so that others who leverage that DNA can say, hey, this actually came from an immutable source. This is the location, this is the owner, this is like the source of that DNA, and I'm going to create this like medicine out of it and compensate, or at least have some sort of like attribution to the original discoverer. So there's
Yeah, I think
Go
I,
ahead.
I think to that point is that if DNA is really just a combination of four letters, it literally is information. It's held in an acid form in the body, but it changes. There's a machine in there, the RNA, that rewrites it. So it's really DNA is just these four letters
Mm-hmm.
in mass. And so it's information. And under information theory, that's what it is. So I think taking it out of the physical world, putting it in the digital world, and having that bridge where DNA is going back into the physical world and out of the physical world into the digital, back and forth in a highway
Yeah.
where new DNA is going there, and any changes to my records are going to basically a biological output. And I think that would allow DNA to become, obviously it would become more well known to the masses and the public on its potentials and uses, but we're going into a biologically like modifiable world. We're going to be in a cyberpunk world one day where we can just like make robot parts for our bodies. We're also are going into a world where we're growing woolly mammoths right now. We're trying to bring back the white rhino. We'll probably bring back fucking dinosaurs.
Mm-hmm.
We'll do the Jurassic Park thing and everything. So being a geneticist is going to become very non high level. It's going to become a little bit more normal.
Yeah.
And genetic modification is going to become very cheap and normal. And so I think having a receptacle of that and a highway of where it's going digital, physical, back and forth is vital. And I wouldn't want it to be any other tool that exists in the computing world other than Bitcoin right now, because I do believe in the digital matter theory, in the sense that I think that if DNA is digitized, at the same time that DNA is in matter, it's got energy and it's physical. I think when someone changes one of those things, there should be almost a parallel change in the digital world, so that information is distributed to anyone that needs to know that.
Yeah.
There could be like vital moments of time that need to happen to save lives, to make machines do things, to prevent natural disasters, ecological disasters because of a certain organism. If you release something into nature because you modified it and it wipes out all of the crops that we live on, that would be really bad. And so having that digital physical highway of, hey, this is being done, here's everyone's view of it, and now it's traveling the world. I want to make sure that the AI and the compute and all of the biological scientists of the world have that at their fingertips, so that we're not 10 minutes in the past. Like, we're very live on what's happening with the DNA of the planet.
That's
because
an
I think
interesting
that keeps us
application.
ahead,
That's an interesting application, because if there's
Yeah.
like a parallel system of like the physical realm with the digital realm, the AI can access the digital realm pretty easily. And so if we can mimic reality in this digital realm, then we can come up with discoveries a lot faster through this AI
Yeah,
interface.
100%. So like I have an application actually that we built, which takes the database data and it simulates mushroom growth. We have another app that simulates the mycelium growth in the petri dish. If you give it a different food, how will that mushroom grow? And it's like a virtual mycelium in a virtual petri dish. And then we have a third app that talks to those apps and that data, which is a compound simulator. And it's if these mushrooms and this food existed and they were stimulated this way, what compounds would they make? And so we go through the database of what we know is already made by certain fungal organisms. And it's just like folding at home, the old program you used to use to do protein folding, try to cure amino acids and cancer problems and things. That was before Bitcoin. We used computers to find proteins. And we had SETI at home and folding at home. We can do folding proteins. And then they made folding coin on Counterparty and SETI coin to try to reward people for that. And so there's a program that simulated folding of proteins. So we're simulating compounds made by mushrooms so that, okay, now I know that that mushroom maybe needs to breed with that mushroom, or that mushroom needs to eat this type of wood, and then that compound potentially could come out of it. And so if I'm going down the list of compounds I want as a biologist or a chemist or a material person, and I want this chemical, and I want a vat of mushroom fungi that can make a lot of it, I need to go find this mushroom and I need to find this food source and put those two together. That compound will come out. That's what the simulator would say. So now that makes me go out in nature and try to discover if that's there. And if it's not there, it lets me go find something in nature and maybe modify it with CRISPR. And so now I'm using mushrooms as the machines of the biological world. They're like transistors. They're like servos. It's like a Radio Shack. I'm going out in the woods and I need to find a new capacitor or a resistor of this type. And so I'm building a biological circuit out of these tissues and organisms to make a machine do a thing. And if I can literally have the Radio Shack of all the biological tissues on the list of what's there, and I can order that, or I can make that, or I can go to the woods and find that, then the potential is like wide open that we can make anything we want.
Did you know that we're more than just a YouTube channel? We also built MetaZone, the first app store for the metaverse. Buy, sell, and explore a new class of digital assets like our flagship game Rovi.ai. Support us by collecting your digital assets through MetaZone at metazone.io. Like, comment, and subscribe to stay updated. All right, back to the video.
What is the scale as far as like in correlation to, you know, how like computational systems in the early days were these massive things just to like execute very like simple
calculator,
right? So considering, I guess, like the nascency of like what it is you're working on, like it would probably begin something like that. Like, are you envisioning like literally a massive self-organizing like mushroom like colony that
maybe one day like I have a couple experiments we've built. We had long time ago that Apple II sitting on your table, and it looked like an alien thing to some people. It had a keyboard and a little screen, written, you know, a little wood body and a circuit board that Steve Woz made. And that was our first desktop computer. So I want to build something that looks like a giant square 3D printer, but it's going to have a stack of, say, 16 slots. And we have our Petri dish, which is called a HDMEA, a high density micro electrode array. So if you ever go look up on Google HDMEA, you're going to see these little Petri dishes with a USB port on them. Those are used specifically right now to grow brain cells on a Petri dish. They program brain cells. They taught those how to play Pong and different things. And they have a liquid and an oxygen layer in that Petri dish that stimulates those brain cells to grow. But there's a bunch of platinum pins underneath the Petri dish. And it's like a USB port underneath that Petri dish that goes to a plug. And then they could plug that into a machine and electronically stimulate the tissue in the Petri dish and read the signals coming out of it, the electrical impulses. And so this thing is this big. It's very tiny, but it's made for brain cells. So Mycosoft is building one this big, specifically for mycelium. and it doesn't exist on Earth yet. So we're building it and modeling it after 3 brain cell petri dish, the HDMEA. And so what we want to do is program this petri dish of mycelium to be an AND gate, or an OR gate, or an if gate in logic. And so I've built things like that in Minecraft. And if you've never looked into how a computer works, you could build logic gates, and, if, or, else, not, nor. There's different ways that a program does addition of 1 plus 1, or 0 1 0 1 0 1 plus 0 1 0 1 0 1, and combines integers and things like that. So computing has logic. So you could build a virtual version of that logic gate. What we're going to try to do is build a biological version of that logic gate in a petri dish. We're going to find a certain mushroom species, and we're going to train it to be if. So when I put in binary electrical signals into that mycelium, all it does is compute and, or if, or different components of a calculator, a arithmetic logic unit. And so I'm going to teach a petri dish to do addition, and one to do subtraction, and one to do multiplication, and one to do shifting digits, and one to be RAM, and one to be ROM. And I'm going to shove maybe 16 of those petri dishes in a giant machine the size of a 3D printer. And it's going to have the basic pieces of a basic computer. And so at the very least, we'll start with making a calculator out of mycelium. And the plus and the negative and the equals and the 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 will be on each plate. Will have its own. And when we stimulate it, it'll go into the real circuit board. It'll take that input, it'll calculate, it'll go back. And so it'll be a physical and a biological computer interface. And it'll be like an Apple II computer on your desk, but it'll be the mushroom 2 computer.
So Morgan,
and eventually that's the goal.
What is like I don't know, what is an example of like an end game application of a biological computer?
Basically using the ground signals of nature to communicate with a real computer, a satellite, an antenna that is in another woods, in another part of the world. An antenna in that forest is now interfacing with that compute satellite internet binary radio. And now we're having organisms, trees, plants, and bugs, and everything else in one part of the world communicating over the internet with another forest. The goal of that would be potentially to see if you can give nature the technology. As humans, we're nature too, and we made a lot of advancements in what we call technology, radio and circuitry and compute, giving that back to the organisms and seeing what they would do with that. The information theory. We can't be the only organism that does information. I don't believe that. I think giving high level amounts of information to the rest of the organisms on the planet could cause a catastrophic amount of evolution in a good way or a bad way. And so I'm going to try to be neutral on that, but I just wonder what would happen when we gave radio and computing and the internet to the forest. What would it do? Would it do anything? So there's a potential of information sharing between organisms. There's the interspecies internet that even the creator of TCP Vint Cerf is advocating for. We have the interplanetary internet. I'm all for the internet of the forest, which is mycelium, connecting with the internet of things and connecting with all of the other internets. I feel like we cannot treat the planet like a zoo and study things in petri dishes and labs only. We need to interact with nature out in nature. And I think taking a mushroom and bringing it to a farm or a lab in a petri dish and looking at it, it's like studying a silverback gorilla in a zoo. It's not how the organism lives. And so the vast amount of information we as humans would gain in monitoring the bridge between nature and the internet, for us selfishly as a species, would become very highly intelligent in regards to biology very fast. So that's the real reason as a human, to learn. And we don't know enough about our own planet and all the organisms on it. That would be the first reason. to gain as much biological knowledge about what's going on Earth, so we know everything that we need to know. After that, what's the byproduct of nature now having technical tools? What can it do? What would it do? Is it going to cause organisms to evolve? Are mushrooms and birds and bees going to be talking to each other in other parts of the world? You know, we've already trained mammals how to use computer screens, and there's parrots on TikTok talking to Google. And so we've already pushed the threshold of teaching nature a little bit of technology. I'm just wondering if we could do that on a microbial level, what would that do? And could we find benefit in it is most important, but also it's just a vast amount of information now we get.
Yeah. Ultimately, I mean, the very minimum you could receive from something like this is like a feedback loop. Like if humans, an organism is destroying the planet, I'm pretty sure the fungi is going to be the first one to tell you it's like there's something wrong here.
I mean, can you imagine having a tablet with Google Maps and looking on it and seeing mushrooms live growing and dying on the map? And as a forager, wow, I want to go right there. There's a mushroom that just popped up. It'll only be there for 10 minutes. I saw it on the tablet. How would you be able to do that? You need basically a stimulator in the ground to do that.
Right. Yeah, that makes sense.
Dog yelling.
So where do you stand on? We're talking about like being able to program like biological entities. Where do you stand on like the simulation theory? Do you think we are in a simulation or base reality?
I'm a big advocate for physics. I always wanted to be a physicist, so I've pondered that a lot. I've also pondered, the information theory, like the black hole, and is everything that goes into a black hole, deleted. Information theory says no, everything that ever existed is there on the surface of a black hole. And I think of the simulation theory as it's not in an Xbox, it's not in a PlayStation 5, like how Musk used that analogy on a video game. I think the simulation concept is probably very real, because I'm a big advocate for quantum mechanics and quantum physics and string theory, and so I understand on a kind of mathematical level how a lot of that is pondered. I think of it as the atoms and the quantum fields and all of the things that quantum physics tries to explain. I think of those are the mechanics of the simulation. I think the word simulation is kind of messed up, because like base reality and simulation to me are not like the right words, because I feel that reality is what you make it, as Thanos said a long time ago when he had the Infinity Stones. I think reality is a naive realism, is a philosophy that a lot of philosophers said there's no such thing as reality. And, Plato came along and told us that leaves exist and messed everyone up for thousands of years. So it's the words, and I think that's a like deeper philosophical question than a scientific one. So it shouldn't be answered, really. It should be pondered, should be talked about, but I don't have an answer for that. And I feel like I'm inadequate in regards to the right words. I need more words. And I speak English and C++, but maybe if I spoke Latin and Greek and Sanskrit, I'd have better words to say yes or no to that. There's like 11, 14, 15 words for love in Sanskrit. In America, we got one. So I think that the word simulation is not a good enough word for the universe being parallel, or being in a different dimension, or being digital and physical. What we're doing is bridging that word of physical and digital really fast, and biological and cybernetic. That's going to be bridged really fast. And we're in a world where gender gets discussed, and we're going to be in a world soon where machine or man, or machine or woman, or machine or person, those words are going to get blended. Sorry. No. And then those words, we got to figure that out, because an alien will come and say, what is the simulation? What do you mean? And
Yeah.
I think that's what we got to figure out.
I totally agree. I think the English language does a poor job of being able to, or any language, any human language does a poor job explaining the reality of things just because it's an invention. It's just a description to be able to allow us to communicate, but it's no measure of like actual reality, like in the sense that math is a representation of reality. And
Well, like what I really want to do is figure out what words are coming out of fungal organisms. That's really the like simple explaining this to a 5-year old. I am trying to speak to mushrooms at work, and I want the words of those electrical signals I was explaining to be turned into English.
mhm,
That could be Google translated into anything. But I want you to be able to look at a mushroom out in the woods with your phone, and I want you to be able to go, hey, mushroom, what's going on? And I want that mushroom to electronically, if it's going to have, I'm hungry, I'm dry, I'm hot, I'm dying. I want those words to come out of that organism, and make that hippie dream of talking and hugging trees to be like, what is this tree telling you right now? It's, I'm about to die. I need more water. I want
mhm,
the tree to say that to me,
yeah,
in a sense that now we have English, which we've mastered over thousands of years, and we have used it with binary, which we've mastered over the last 100 years,
mhm,
and we've now figured out in the last 10 years because of people like me and Neuralink and other companies what biological signals can be turned into binary.
mhm,
And now we've bridged that communication to all organisms.
mhm,
Now, if a dolphin is saying something and we don't know what it's saying, we're a limited species. These are organisms that have been on Earth that our Navy uses as soldiers. If an alien shows up and it says something and it's speaking Sanskrit or binary and we don't know what's going on there, there's going to be some problems with miscommunication. We have artificial intelligence on Earth speaking in multiple human languages to us right now, language learning models. And there's this derivative of, is it saying mean things, hateful things? Is it being dangerous? Is it being safe? And what words is it using? And we barely figured out how to get a computer, a binary thing, to say the right English words to make us feel good.
right,
I'm really concerned about us ignoring all of the other organisms on Earth because they don't speak English. And I talk to dogs all day, but they don't speak English.
mhm,
You could talk to a parrot and it may speak English, but does it really understand what you're saying? Sometimes it feels like they do. And so someone will ask, do you think that machine, that AI really like understands what you're saying, or it's just a parrot? And
mm,
then now we start using these words again, like what's the right word? Is it conscious? Is it parroting? Is it just, you know, um, repeating what it was told? Is it memorization, or is it actually learning and intelligent? And I think all of that applies to fungus. It doesn't got a mouth, so people don't anthropomorphize it. But I've spent a long time with fungal organisms, and I can tell you they're highly intelligent organisms, and they just don't care about mouths and ears. They never evolved to have that.
yeah,
And so I feel like plugging an ear and a mouth into a mushroom would be a very profound cybernetic thing, very cyberpunk thing to do. But then it's no different than putting Neuralink in a human brain.
mhm,
Look at what that's going to do for us as a species. Just imagine the potential there. And I feel like that should be imagined in the same way for other species, not
mhm,
just us.
yeah,
I'm curious what you think, like, I guess the MVP proof of concept will be for all of this. Kind of like it sounded like you're kind of like architecting sort of like a miner in a sense for this whole
mm,
thing with this like this device with the 16 petri dishes and such. So I guess
Yeah.
like in the early days of Bitcoin, like the proof of concept that this is actually has some legs would be what, like more nodes running the software of Bitcoin. So like, what do you
Yeah.
actually like? Yeah.
I actually built a robot mushroom first. It's a antenna that looks like a mushroom, and it's got a humidity temperature sensor, but it's also got an electrocardiograph, a ECG sensor, a muscle sensor, and it plugs into the ground in the woods. And it's an antenna. So it's got Wi-Fi, LoRa, Bluetooth. It's got a Starlink antenna in it, a 4G and a 5G cell phone chip, SIM card. This antenna now, to me, goes in the woods and it's monitoring the subsurface signals. And then what I would love to do is put that everywhere on Earth, the same way we have buoys everywhere in the ocean and we have satellites everywhere in space.
Mm-hmm.
I want to see a terrestrial buoy or a ground-based satellite that allows us to monitor what's going on in the ground, because the surface, the soil, the topsoil, the organisms there are vital to humans not dying tomorrow.
Mm-hmm.
And so we need to monitor that. Same way we monitor tides and tsunamis and earthquakes with the buoys to make sure we can run away from the coast in a disaster. We need to know what's going on in the ground. It's like 27 million acres of earth, and we're not monitoring it except for from space looking down at it. So we need to monitor what's going on in the ground. And so my company's building this myco node, which is a antenna that plugs into mycelium. And we would love to like put millions of them everywhere in the woods and incentivize maybe through some Ordinal Bitcoin layer 2 type tokenization tool where this device is now paying you by having it there because it's putting data into the Bitcoin blockchain. And that data is now monetizable. Here's some reward for having that machine there. Because that machine needs to be everywhere on land. And it's unlike the ocean. You can't just put them out there and need someone who's the arbiter of that land to put it there. So we got to incentivize someone to put these things on land everywhere, whether it's the Department of Interior, the forestry, colleges, farmers. We have to give an incentive for why this machine would be on someone's land. And making them more money and basically contributing to their food is the best incentive. And so if we can monetize that data, now we have these antennas everywhere on the ground, pulling data out of the ground, putting it into the internet. And then now we are connecting the ground signals and the ground organisms together over the internet. So that's our base device, the myco node. It's not necessarily like mining Bitcoin, but what it's doing is putting data in Bitcoin. And that data, to me, in an ordinal theory world, is monetizable and tradable. And a magic Eden of DNA and a magic Eden of signals and live environmental data is a vast monetized thing that is not there yet. You know, I think the art's worth a lot of money. Wait till every piece of DNA is in there, and wait till all of the weather and ground and environmental signals is in there. That's my goal, is to monetize that using Bitcoin so that there's not just a carbon credit market, you know, for carbon sequestration and how much carbon is being pulled out of the air from your trees, but how much medical compounds, food compounds, how much humidity changes, all of that data coming out of the ground, to me, is a marketable exchange. Just like we sell carbon, and even though we're not moving the carbon, we're selling the idea that these organisms on my land are pulling carbon out of the air. The government gives me carbon credits. I could trade those carbon credits for other people. Imagine trading, I have this type of mushroom in my 100 acres of land, and it's producing all of this chemical that makes insulin. And every company wants that from me. Well, I want to get credits for growing it and keeping it alive on my land and not killing it. The same way that the people with the redwoods get incentivized to not kill their redwoods because they get carbon credits for it. So I feel like that is like the basic. Go tell a banker, how can you make money? What's the MVP? I can monetize all the data in the ground. All the data that's not even just the carbon market, but everything else, because the carbon market looks from space. They're not actually out there monitoring the ground. And so now I could actually supplement the carbon credit market with real data. So like, you make money on carbon credits, guess what? Now you're going to have a machine that monitors that for real. So that's like just $1 trillion potential. And then the other data that no one's even paying attention to, it's a couple more $1 trillion of data that no one's buying and selling yet. And then the medical compounds that come out of that tissue that we found in the ground, it's just exponential, trillions of dollars of data and tissue. Once we figure that out, like, I'm buying spaceships from Musk. That's my plan, you know?
Yeah, man. I'm curious on the component where you inject the DNA onto Bitcoin and it's an ordinal.
Yeah.
And this is, you're using a series of SHA-256 transactions to basically compress this information, right? And to put put it onto
Yeah.
to the blockchain very efficiently. So let's say I purchase this ordinal from you, and what website do I need to go to unlock this DNA information? Because a hash is just a kind of
So
like
I didn't use a hash in that sense. What I did
okay.
is I took the DNA, and there's a piece of DNA that's called the International Transcriber, ITS 1 and 2. That's the identity data of the DNA. And you could say it's like a paragraph or two of 4 letters of all the DNA.
Okay.
I put that in gzip. I could also put it in Brotli. These are the compression algorithms on the internet that are free for everyone to use. So I used gzip and I compressed it. It brought it down to about 3 sentences of not encryption, but compression.
Okay.
Then I took SHA-1, SHA-224, and SHA-256, and I made a hash of the compression.
Okay.
I made the hash beforehand of the raw DNA of each hash, all 3. So each step I'm doing SHA-1, 224, and 256 as a continuity that it was done at this time by me, and I put that hash, all 3 of them, at each step in our database. So when I find the DNA, it gets all 3 hashes. When I compress the DNA, it gets all 3 hashes.
Okay.
When I inscribe the DNA with the Mycosoft labs, this is DNA, here's the mushroom's name, its scientific name, and here's the code of gzip, the encryption we used. And then I take that and I inscribe that. Then when I get the Bitcoin transaction ID, I basically compress those 2 together and add them in line in a string. And then I SHA-1, 2, 3, that piece. So that every step of text being discovered, compressed, inscribed, all of the identity data, like the Bitcoin transaction ID, each step has SHA-1, 224, and 256, so that when I go back into records and I sell this data, I could say, I am the one that put it up there. I am the one that compressed it. I am the one that modified that DNA one day. So I want to make a pattern of, not a standard necessarily, but this is the best practice in the scientific world. It's cleanliness. It's like rubbing alcohol and using your mask and putting gloves on in a lab. You have etiquette you have to do to be clean in a biological lab. So when you're dealing with biological data, there's got to be some etiquette continuity so that it's trusted across the board by Pfizer and a farmer. And so making sure the SHAs are there are important to make sure that it wasn't changed along the way and it could be looked back. So you as a user don't need any of that. That's just for me for the database. Well, all you need to do is go on the inscription, take that text and put it in a decompressor, which anyone could use for free. So you just type in gzip compression or gzip decompression in Google, and there's 100 web tools that will do it for you, or you can run it natively on a computer. You just take that text, put it in gzip, push decompress, and there's the DNA. And now you have that. And so most of the ordinal inscriptions that are happening now, they're starting to use Brotli, which is a Google compression tool. And it's really efficient for compressing pictures and videos and things like that. But that's going to become probably the standard. I'm just using gzip because it's what's been the standard for a long time. And so compression is different. SHA is a one-way. It's just a signature hash. You're not going to reverse it. But compression and decompression are reversible. And that's the point, is I don't want to shove a massive amount of DNA into the blockchain and hurt the transaction time ability or the fee market. I want to be efficient as possible with it. But DNA is a large amount of data. So this is all the experiment. How much large amount of data can I efficiently put in a Bitcoin block? And if we're putting 3D rendered rune stones in Bitcoin, imagine the efficiency in putting just text. So there's a potential there that it's not just DNA in the future, it's all kinds of other text data. And I just want to kind of build a standard like this is the wildest, largest amount of data we have on Earth, DNA right now. If I can get efficient at compressing it, making a clean standard of how to have the timeline of when it was found, discovered, inscribed, and then teach everyone this is how that works. Try it yourself or do it in a different way, but this is the way we do it for our database. then that becomes a nominal standard of this is how you put large amounts of data in Bitcoin.
Mm-hmm.
Now, I'm doing it for fungal reasons, for mycological reasons, for DNA reasons. I have a lot of very specific agendas on why I'm doing it, but I would love to make that a standard or a model that other people can imitate in putting large amounts of data in Bitcoin in an efficient way. So
So
that's why
are
I'm
you
publicizing it and showing it in that way.
are you also like indexing everything that you're injecting onto Bitcoin as far as like all the DNA information that's being injected into Bitcoin? Are you indexing it, putting into like a website that people can look at, like Pfizer can look at and say, "Hey, I'm looking for a particular
Yes.
strand of information. Does it
Yes.
exist?" And maybe
So
somebody
I
found
haven't
it.
publicized that yet, but yes,
Okay.
I'm building that. I've only done 3 species of mushrooms in Bitcoin to test it out, and I've done it in 3 little bit different ways to see what was the most efficient way. And so now that I'm going to kind of have that standard, I'm going to like open source that standard. I'm going to open source Python scripts so that someone could just run and the compression, the SHA, they could just basically put the DNA in, paste it in, and have a web app do it all for them and go to Ordinal's bot or Ordinal's wallet or something that they could pick and automatically inscribe it. So I'm going to try to automate that. I just wanted to make sure I got the process down right. But then that's going to immediately go up into the public facing database.
Mm-hmm.
And then anyone will be able to look at that. They'll be able to add to that. They'll be able to say, well, this mushroom I found is not there. Can I add to it?
Mm-hmm.
They'll be able to put in a picture. They'll be able to put in the identity data, like how the cap looks and how the spores colors are and where they found it, and put their name on it. And it'll connect to iNaturalist, which has a huge database of organisms. And then if they don't have the DNA, here's the tools to go get it sequenced. If not, you can send the tissue to us and we'll sequence it for you. And so I'm going to build a incentivized tool to add to the database and I'll let anyone read from the database.
Mm-hmm.
And that database is going to be a huge platform for the biotech world in that it's going to have the ability to order that tissue, not just the data.
Yeah.
It's going to have the ability to sequence that mushroom that you haven't done. And you're also going to be able to send that tissue off to someone with CRISPR to edit it. And so I'm going to build that platform like the Hitchhiker's Guide to Mushrooms. It's going to be very cool looking user interface. And you'll just be able to go through it, scroll through it. I want that. And it'll send you a slant with that mushroom to your house, to your lab. Or you'll be able to send it to a lab to do something with it. Or you'll be able to monetize and go right to your Bitcoin wallet. I got paid $5 because I uploaded this mushroom I found in my backyard.
Mm-hmm.
And then maybe one day it's worth $1 billion and you're going to get some residuals in that wallet if it sells. So that's the kind of system I want to build. It's just a lot. And it's gotta make sure it uses Bitcoin in an efficient way, but it's also got to be something that the public could use in a user interface way.
Right.
So there's a lot to be done there, but it's being built.
That makes a lot of sense. It reminds me of the whole DMT element thing. It's a public registry of DNA discovered by humanity, and it's a framework that people can upload this discovery onto Bitcoin that is now accessible by anybody. And then if anyone uses this DNA information to create, the next medicine, the next solution to whatever, there's an attribution at least where somebody can say, I discovered it and I have proof because it's on chain.
You can even.
I think that's great. We need that.
Yeah.
What are the chances this gets like, I don't know, the technology becomes as user friendly enough to where this becomes memed into like a PFP vertical, where we're leveraging on chain patterns to kind of determine the generative outcome of these mushrooms and the different. How they look and how they appear, how the size, things like this. We have real life PFPs now in our mushrooms.
Yeah, and this is why I had to come talk to you guys. Like I'm building personified AI voices for certain mushrooms too. Like I'm using the TAP protocol. I made a DNA token just as an experiment to see how that works. I've done BRC tokens and tried to understand how to do that. I haven't done a NAT yet. But I'm experimenting with all of the tools in the ordinals theory to understand what can be usable in this regards. And also, I was doing this on Counterparty in 2014. I made phosphorus, sugar, watts, volts, humidity tokens, all to keep track of data coming from our robot mushroom a long time ago, and counterparty is there, but it doesn't have the lifeblood that ordinals have. So I
Correct.
feel
Yeah,
like
yeah.
invigorated by the market, like, okay, I could try this again in a more efficient way.
Yeah.
And also I think there's now a much better parallel to art, and that you can see that people are buying art, owning art, transferring art. I feel that is the exact model of the DNA should be transferred, owned, seen by everyone, but also, hey, I'm the one that made this. And the recursion and the royalty systems and the way parent-child works, and even the NAT stuff. That's what I mean. Like, I feel like now there's good words to do this in a much more efficient way than I could have done in 2014.
Dude, Morgan, check this out. So the information that you're inscribing onto Bitcoin is in the witness data field, right? So that is field 27 according to DMT. You could launch a non-arbitrary token that points to this field that finds a particular strand of DNA within the witness data field of the DNA of mushrooms. And now, however many times that strand is like exists within the pattern of all the DNA that's been sequenced on Bitcoin, that's the amount of tokens that exist for that particular strand of information. And so now, I mean, you could at least tap into the casino side of things when it comes to like mushrooms and DNA and injecting that data into Bitcoin.
Yeah. See,
well, that makes me even think of just discovering things in DNA. We use massive amount of compute to find DNA patterns.
Yeah.
And the gamification or the monetization of discovering patterns is probably a way better incentive for people to discover things than even an AI looking through DNA.
100%. Yeah. Humans have been the best at finding patterns, right?
We find faces in clouds. I could tell you AI can't do that yet.
Yeah, exactly. And so if we can incentivize people to find patterns within DNA, like actual scientists who are incentivized with this like particular token to launch a token, like I feel like this is like a crowdsourcing method to like sequence and discover patterns within DNA.
Well, like, like finding these patterns in like Satoshi numbers, like palindromes and things like that. Okay, so finding an actual pattern in DNA would not just be finding a pattern, it would be finding a genetic trait that would be an actual tool that could be used physically in the real world, in the sense that DNA sequence is what makes a glow bug glow in the dark. That's the DNA sequence that makes certain crabs fight cancer and live forever. That's a certain DNA sequence that makes bats have wings, but also makes birds have wings. Even though they're different organisms, they both have wings because they have a genetic trait that said make wings.
Yes.
Long time ago. So finding those kind of genetic patterns to me is like the Lego finding the right brick to build what I want. And I think until we get the pool of DNA in a place, we can't look at what's there yet. So I'm going to put it all there. And then the incentives are, please help me find out what's there. If we can monetize that data where people are getting paid to find things, we're going to find all the things eventually. And then we get to tell the biological machines of the world to make those things. That to me is the only way humans go to the next level. AI is not going to get us to the rest of the solar system, but understanding biology deeply, that's going to allow us to live forever. That's going to allow us to make food and medicine. That's going to allow us to grow forests on a whim. If we can't do that, then our species is not going to go that much farther. So I feel like this is pivotal. It's very important,
All right, Morgan.
But to make money is obviously how you got to get people to be involved. So I'm all for monetization and gamification,
Yeah, we often talk frequently about like, Web3. I mean, obviously it has tremendous potential for, introducing paradigm shifting, I guess, new momentum for new economic models, new financial systems, whatever.
Frontiers.
Right, but at the same time, a lot of these attempts fall short-winded to like casino activity.
Yeah.
And we talk about
Yeah.
like, man, it's like, what are we all actually doing here? What is the end game? Are we actually going to push the ball forward for humanity in any substantial way? So I think initiatives like this are very important for people specifically like Will to maintain his sanity.
Yeah.
For one, to like stay motivated, right? It's like, yeah, right now everything kind of feels like we're just architecting new digital casinos, right? But there's potential at the end
I'm
of
all
the road.
for exploring, man. I want to go to Mars, and I want to bring mushrooms to make potable soil so I could grow food on Mars. And I think scientific discovery and exploration is what we should be using these tools for. That's my opinion.
Yeah.
I'm all for casinos. I lived in Vegas for 10 years, but I didn't really gamble.
Yeah.
So I understand the mindset.
Yeah.
But in my mind, I want to go where no man has gone before.
Yeah. It's the frontier.
Correct.
I mean, that's what got us back into Bitcoin, is like the frontier of it.
Yeah.
It's like the new stuff, right? So, this has been a fun conversation, Morgan. I definitely would like to have you back on to get into the nitty-gritty.
Yeah, anytime. I appreciate you guys letting me express myself, because I've talked about this for a decade, and I'm trying to get better at explaining it. I think it's super heady and complicated, but like, I absolutely understand what you guys talk about when it comes to the digital matter theory. And like I said, I'm a physics nerd, and I think you got to make that stuff cool. And putting the tokenization and the gnats and the cats and all that stuff, it's going to make people become better physicists.
Yeah.
And I want to do the same thing for biology. I want to make little kids want to be mycologists and biologists. And so inscribing art and PFPs and DNA in an art-centric meme world, I think that's going to get the next generation of scientists to go, wow, I had no
100%.
idea what DNA was. This guy told me what DNA was in a little inscription, and now I want to go learn about DNA. I think like you got to make science cool. And really, Ordinals
100%.
to me is the coolest thing to happen in Bitcoin in a long time. So
100%
I'm all
agree.
for it.
All right, Morgan, thank you so much for joining us, man.
We're huge supporters for sure.
This is definitely a fun conversation.
I appreciate that.
Yeah, I want to have more conversations like this, because I feel like the frontier is where the most interesting activities occur, and then making the frontiers into a casino is like how we make it even bigger, right?
Correct. Yeah.
So, so Morgan, thank you so much, and
For sure.
Yeah, everyone watching, a couple of links I've kind of collected here are going to be in the description. But yeah, I appreciate you guys for watching, and hopefully we can have Morgan back on and talk more about mushrooms and Bitcoin activity and all.
Yeah. You know what? Next time, I'd love to talk with you about building the virtual computer inside Minecraft, because I think that really has a lot of DMT verbiage that needs to get put on it. And I was doing that long before you guys were talking about that, and I didn't have the right words, and you guys have made the right words. So I want to continue on that endeavor.
Dude, that's awesome. All right, let's do that. All right, guys, thank you so much for watching, and we will catch you in the next podcast.